Hi guys, welcome back to our channel. So today I'm going to demonstrate you how to develop machine learning models, how to develop various machine learning models for the problem statement HR analytics. So what do you mean by HR analytics? HR analytics means here we are building predictive models which can identify whether the employee is to be promoted or not. So in HR department, it's a key problem to make a decision who is to be promoted and who is not to be promoted. So here we have a data set which has been downloaded from the open source, and we are going to develop various kinds of models. So at first, as usual, we import the libraries. I'm importing pandas to create a data frame, and I'm importing matplotlib to do the data visualization, and also I'm importing seaborn. So if you don't know, or if you don't have the basics of doing the data visualization, so you can refer our earlier videos on pandas, matplotlib, and seaborn. So once these libraries are imported, we'll go for importing data sets. So this is the trained data. So we have a separate file for trained data and also test data. So here we are creating two data frames. The name of the data frames are train and test. Then I'm looking at the header part of the data. So head of 3 means it is going to display first 3 rows. So these are the variables in the data set. Employee ID is there, department, region, education, gender. We have 2 values, male and females, and other variables are recruitment channel, number of trainings held, age, previous year, rating, length of the service, and KPI, key performance indicators met greater than 80%, number of awards won, and average training score, and this is our target variable is promoted. So it's a binary classification problem, so you have to make a decision whether the employee is promoted or not, yes or no, or 0 or 1. So we can consider 0 means not promoted, 1 means promoted. And looking at the header part of the test data, so test dot head of 3. As you know, in test data always one column is less, that means target variable is not available. Even we can check the shape of the data. So train dot shape, you have 54,808 rows and 14 columns, whereas in test we have 23,490 rows and 13 columns. As I mentioned, one column is less. And then having a descriptive statistics. So first we need to understand the trained data so that we can develop an efficient model. So what is the trained data says? So train dot describe, we are describing the trained data with default numeric measures like count, means the number of rows, mean, average, standard deviation, minimum value, 25 percentile data, 50 percentile data, 75, and maximum value. As you can see, minimum age of the passenger, the employee is 20 and maximum age is 60. Next, having a descriptive statistics of test data. In the test data, the minimum age of the employee is 20 and also maximum is same, 60. And the number of training held, maximum 9, minimum is 1 training. So this is the descriptive statistics of train and test data. Next immediate step is we can check for missing values. So train dot is null, so this will return true or false, and then summing up the values. So we have the numbers for each column here. So 0, the value 0 means no missing values, and you see in education we have 2409 missing values. Similarly, in previous year rating we have 4124 missing values, means 2 columns are having missing values. Similarly, checking the missing values in the test data, so we have same in education 1034 and previous year rating 1812. So both in train and test data we have 2 columns which are having missing values. And then having a information means importantly we'll try to know what are the columns and what are the data types, and at the end you can also see the summary. So there is one column which is a float 64-bit, which is this previous year rating, and then integer 64-bit. There are totally 8. So here is the 1, here are 2, then these are also integer 64-bit, and then object type there are 5. So these are object type. The memory consumption is 5.9 plus MB megabytes. Next we'll go for data exploration, and it is very important to do the EDA. EDA stands for exploratory data analysis. So there are methods like univariate means exploring single variable, and then bivariate means exploring two variables, finding the relationship between two variables, and multivariate means more than two. So we have to find the relationship between the variables. Then we come to know what is the relationship between the target variable with other variables. So without doing EDA you cannot develop a successful model. So I'm getting the value count for the variable is promoted. That means how many samples belongs to 0 class and how many samples belongs to 1 class. As you can see, this is imbalanced data. So 50,000 plus sample belongs to the 0 class, and only 4,668 samples belongs to the class 1. So this is imbalanced data. Then having a count plot on is promoted using Seaborn SNS dot count plot of, on x-axis we are showing the values of is promoted. Count plot means we are having the count of values on y-axis. So data is trained. So this graphically shows the number of samples in 0. So this is which is more than 50,000 here, and in 0 class you have numerically we have seen here 4,668. So this is the count plot. And then education dot value count. So we have missing values in education, and which is object type, and you can see bachelors, the employees who are bachelors, who are having bachelor degree, are 36,669, and masters and above 14,000 plus, and below secondary is 805. And then so this is an example of univariate analysis. Then comparing two variables here, education versus promoted. So having a count plot on x-axis showing the values of education, and data used trained data compared with the target variable is promoted. So here it gives the graph. Look at this, masters and above. We also have the lesson. 0 is represented with the blue color and 1 is represented with orange color. So majority of the people are having the bachelor degree, you can see graphically here, and below secondary there are less, as we have seen 805. So this is a count plot showing the relationship between the education and promotion. You can see the count on y-axis. Next, this is also an example of bivariate analysis. So gender and is promoted, plotting a count plot. So gender means we have two unique values, females and males. As you can see, majority of the people are male. The promotion also more in case of males because their count is also more. Next, distribution plot. So this is an example of a univariate analysis. We'll see how the values of A's are distributed. SNS dot distribution plot of A's, and KD is equals to true. KD stands for kernel density estimation. So you can have a line. If you don't set KD equals to true, then this line will not be appearing. So with our naked eyes we can see there is a skewness. So what type of skewness? What type of skewness? The slope is towards the right side, so we can say there is right skew, or in other terms we say positive skew. And count plot on previous year rating. So this is also object type here. Sorry, previous year rating is float type. So the rating values are 1, 2, 3, 4, 5. So majority of the people are having the rating 3.0. Next, exploring department and department compared with the target variable. We are specifying the figure size here, 14 by 6. Then you can see the graph. Department, these are the various departments like sales and marketing, operations, technology, analytics departments is also there, R&D, procurement, finance, HR, legal. So most of the people are belonging to sales and marketing. The count is more, even the number of promotions are also more in sales and marketing. Then relations between recruitment and the target variable, count plot. So these are the values for recruitment channels, sourcing, other, and references. You can see the count on y-axis. So majority of the people are recruited through other channel. Even the promotions are also more in other channel. And is promoted versus age. So age is numerical. So we cannot apply count plot on numerical data. So we can go for plotting a histogram. So at first we are specifying the figure size 6,4 and then having a histogram on age and also filtering data here. Is promoted is equals to 1 means promoted. Is promoted equals to 0 means not promoted. And we are using colors. Color equals to list of colors here, G comma R. G for green, R for red, and the number of bins, which is equals to 10, means we are going to have vertical bars. And labels, promoted, not promoted. And x-axis title is age and y-axis title is number of employees, and legend is also added. So this gives us the histogram. So by looking at this graph, so who are promoted more? The people who are having the age between 30 to 35. Even not promoted also more. Then having a histogram for length of service versus promoted, similar to the above figure. So we are having the length of the service on x-axis and number of employees on y-axis. You can see the count of the length of service. So most people worked less number of years, like 5 is more, the frequency is more. Majority of the people work for 5 years, 0 to 5 years. So length of service you can see very small in case of the higher number, right? Even you can see the people also work more than 30 years and they are falling into the category not promoted. So that's why in software or in some majority of the industries, so if you work for more hours, then promotions are less, even salary is not going to be increased. So this is practical. So that's why, so if you work for less number of years, then the salary promotion can also be expected higher. And having a scatter plot, train dot plot dot scatter plot. Here having the relations between 3 variables, age, length of service versus is promoted, and having a scatter plot. Color map is Z, alpha value is 0.8, and also we mentioned figure size 8,5. So the cell is running. So this is a color Z, and by looking at the graph you can see the black red color indicates promoted, and black blue color indicates not promoted. So as we have already seen, the majority of the people belongs to the category of not promoted. The promotions are very less. So that's why you can see red colors, red color values, points very less. Then awards won with promotions. So bivariate analysis, we are having a count plot. So awards won, yes, no, right? So majority of the people says the belongs to zero class means not promoted. The count is also more and the promotions are also more. Next, we are setting the specifying the figure size 9,6, then setting the style to dog grid. For more information, you can refer the C-bonds no styles documentation. And here we are having a box plot and comparing three variables: education, length of service on y-axis, and compare these two with the target variable, and lesson or added location equals to 0. It means the library itself makes the decision depends on the free space. So this is box plot. So importantly, if you have the basics of box plot, so this is minimum value 25 percentile, 50 percentile, 75 percentile, and this is maximum. See, these are dark black points represents outliers. So they are falling outside the range, outside the maximum value. So we can consider these as outliers. And then having a strip plot between the three variables: education, length of service, and is promoted. Dots is equals to true. It means you can have the differentiation. So both the males 0 and 1s are separated. In each category, you see this represents 0 class, this represents 1 class. So that's why you have written dots is equals to true. Otherwise, these two are overlapped. So three unique values for education. So this is strip plot. For more information, you can take help on what are the parameters and what is the meaning of those parameters. Then, as we have already identified the missing values in two columns, so let's focus on that. So in education, we have missing values. So train dot education. So education is object types. So if the variable is object types, so we just have only one option, that is we can impute with mode. As we have already found, the mode of education is bachelor's, means majority of the people are having the bachelor degree, so we are replacing with bachelor's. In place is equals to true means you can have an effect on the data. Also doing the same on test data, so filling both in train and test data, so the values are filled. And one more column we have the missing values is previous year rating, but it is numeric type, so we are checking the skewness first. So we have negative skewness. So when there is a skewness in numerical data, the option is you have to impute with median. So that's why in the next cell we are filling the data with median. So previous year rating dot fill NA is the method, and we are filling the values of previous year rating with median and then making an effect. So both in train and test, then the values are filled. So once you have done the imputation, again we are checking missing values both in train and test. So no missing values, so all the values are 0 here, the count is 0. Similarly, you can check out in test. In test also there should be 0 number of missing values, so no missing values. So we have done the data pre-processing, means we have successfully removed the missing imputed the missing values. So next we can proceed for model development. Before that, there are five variables or 5 columns which are object types, so we have to do the conversion, data conversion. So I'm using label encoder from scikit-learn pre-processing. So if you don't know how to do the imputation and how to convert data into numeric, you can refer our previous videos. So we have videos on data conversion and also imputation. So importing label encoder from scikit-learn preprocessing module, then creating object, and then these are the columns which are object type, string type. So department, gender, education, and recruitment channel. So doing the applying label encoder le dot fit and transform train department, also doing the same on test data, gender, train gender, test gender, train education, train test education, then train recruitment channel from test. So these columns are converted into numeric. So label encoder means, for example, if we have male and female, so 0 is assigned to female and 1 is assigned to male. So it will have a column for gender, in that 0 for female, 1 for male. Like this, depends on the number of unique values. Label encoder assigns the values like 0, 1, 2, 3, like that. And then employee ID doesn't make sense. So no machine learning algorithm works with unique values. So we are dropping employee ID, and even we have more unique values in region. So that's why dropping region from train, dropping region from test. Here axis 1 means column. So done. Now we are checking the header part of the data, just to make sure the data has been, no values have been converted or not. You see all these columns are having numeric values. There is no string type of value. Then I just want to list out the columns so that I can copy the column names into the next cell. So these are the columns, left out columns, and creating a variable relevant features is equals to list of the column names, and then comparing this with the target variable is promoted. So we are finding the correlation. So correlation is one of the feature engineering technique which gives us the correlation value, either positive correlation, negative, or no correlation. So here what you need to do is you need to decide what should be there in X and what should be there in Y. So in X we specify the list of features which are to be given as input to the model, and Y should be target variable. So finding the correlation between target variable with other variables, and I'm displaying the values of that. So you can see the correlation values. This is 0.001 department versus is promoted. Education also positive value. Gender has negative correlation. Even this number of training, age, and length of service of course has negative impact on promotion, and the other variables are having a good impact. So the highest correlation is with KPIs made. So this is the one of the important variable which can affect the target variable. Next is awards won. Next is average training scores. So these are the highly correlated features. Sorry. And then I'm going to have a heat map. So specifying the figure size 12,12, then having the heat map on train of relevant features dot correlation. Annotation true means the correlation values are shown, and specifying the line width 0.5. Then this shows us the heat map. So graphically you can see the relations. For example, you see black color means negative correlation, and this color represents higher correlation. This one is 0.66 between age and length of service, like this. Next I'm just taking all these variables into X, relevant variables into X, and Y is target variable, is promoted, and splitting data into 80% training and validation data is 0.20%, random state is 0. So this splits the data into X train, X test, Y train, Y test, Then model always learns from trained data. So here I am doing the parameter tuning and building a first model which is random forest. As this problem is classification, right, classification type, so we are importing random forest classifier from scikit-learn.ensemble, and during the parameter tuning here, bootstrapping is false, minimum samples in the leaf node 3, the number of estimators means the number of decision trees are 500, minimum samples in the uh, minimum samples splitted are 10, the features are selected, maximum features are selected based on square root, maximum depth of the tree is 10, and these are given as input to the model random forest classifier, and giving the name of the model as classifier RF, random forest classifier. Then fitting data to the model means model will learn from trained data, then making the prediction for 20% of test data and converting the resultant values to integer. So we have built a model, then made the prediction for test data. Next we need to evaluate our model. So these are the evaluation metrics like classification report, confusion matrix and accuracy score, which are imported from scikit-learn.metrics. At first we are displaying confusion matrix, then classification report, and then accuracy. So you can see the output here. First is confusion matrix, followed by classification report, followed by accuracy. So this is taking time. So 500 decision trees are built. Random forest is one of the good algorithm, which is an example of ensemble learning. Ensemble learning means you'll build set of models. So as you can see, the number of samples into 0 class are these many, and 15 samples are misclassified into 0 class. The total is 10041. In one class, correctly classified samples are 173 and misclassifications are more. So this is not a good model, even though accuracy is better here, 93%. Even we are displaying the accuracy 93%, but you can look at other metrics like precision is good in case of 0 class, in case of 1 class, but look at the recall value. In case of 1 class, 1.0 means 100%. In case of class 1, only 19%, 0.19, and even FN score 31%. So accuracy is not a good metric for any classification algorithm, classification model. So instead of evaluating a model with accuracy, you can refer the other metrics like importantly recall. Even F1 score is the harmonic mean of precision and recall. So we always expect a F1 score closer to 1.0 means 100%. If it is less means incorrect classifications. So this data set is imbalanced data. Already we have seen that, and even you can see the performance of your model, many misclassifications into the 0 class. So that's why it is very important to make the data balanced, then go for building a model. So we'll see the results with balanced and without with balance and without balance. So 93%. Even I'm checking the recall score explicitly 18.78. So rounded value is 0.19. Then making the classification. So we have a separate data set, right? Test data is given as separately. So in real time also we have the same scenario. So train data is given separately and test data is given separately, and we have to make a decision. We have to make prediction for all the samples of the test data, and you have to submit a result. So here there should be only two things: who is the employee, and then the decision, either promoted or not promoted. So we are making the prediction by using our model. This is our model, making the prediction for test, from test data, getting relevant features that we have listed, converting the result to integer, then creating a data frame here, and in the data frame we are going to have just only two columns. The first column is employee ID, which will get it from test data. And what about the decision? The decision is this: is promoted. So we are getting the value from the model predictions. So that is assigned to is promoted, and the data frame is created, and to CSV we are saving the result to the file summation rf.csv. Index is equals to false, means we don't want to show the save the index. So only two columns, employee ID and is promoted. So you you can see the file in the same working directory, and then displaying the header part of the data submission. So employee ID, then the decision. 0 means not promoted, 1 means promoted. Submission dot shape, the shape of the submission should match with the original test data. So the number of samples are correct, equal. Only two columns, employee ID and is promoted. Then what is the value count of 0 and 1? As you can see, the model has been trained negatively, so that is why the majority of the samples are classified into 0 class. In one class, only 339. Next, I am building one more model. So when you are given with some data set, so it is good to develop multiple models, at least 3 models, and then conclude. If you just build one model and say that your model is best, so no one is going to believe, no one is going to trust you that your model is perfect. So next model is XGBoost, extremely gradient boosted model. So XGB classifier imported from XGBoost module. This is not part of scikit-learn, so you have to install it separately. And I'm doing the parameter tuning here. The number of estimators means decision trees are 200, maximum depth 10, minimum children's weight is 5, gamma subsample, and it's a binary classification problem. So objective function is binary logistic. Number of threads are 5, and then you can see random state also mentioned 45. Then fitting the training data to the model, then model will learn from trained data. So it takes time, couple of seconds. Then using the model, making the prediction, and the prediction results are stored into the expedite. Just have a patience, it will take couple of seconds. Yep, done. So next let's make the prediction for X test and then evaluate the model. So when we are evaluating, the accuracy is 87% decreased, but the recall score is better when you compare with the previous model. It is 60%. So this model is better than the random forest because it is somewhat giving the correct predictions in case of class 1. Then making the submission using the XGBoost algorithm, then getting the count. You see the number of values are increased in case of 0 class, whereas here we just had 339 more, or in 0 class 23,151, that is decreased here 19,942. Next, building one more model, GBM gradient boosting model, imported from ensemble, doing the parameter tuning here. The number of estimators are 500, maximum depth is 10, minimum samples 10, learning rate so 0.11%. Model gradually improves the performance. So fitting data to the model, then making the prediction for X test. So this also takes time. So once the predictions are done, you can evaluate your model with the same metrics. So first we are displaying confusion matrix, then classification report, and the accuracy between y test and GBM predicted, means the actual value compared to the predicted value. If there is a difference between actual and predicted value, we say error, otherwise not an error. So it is still building the model. So one of the drawback of ensemble learning is the model building might take time, because here 500 decision trees are built. So I hope you guys know the difference between the decision tree and random forest. In random forest, set of trees are built and all those trees are used for the prediction, whereas in decision tree, single tree. So advantage of ensemble learning is to have a better model. The accuracy is going to be higher when you apply ensemble algorithms. So ensembling algorithms are ruling actually today for any kind of problem. So they give you the better accuracy when you compared with the standard or no basic algorithms like decision trees, k nearest neighbor, support vector machines. So when you are given with the problem statement, so first apply very basic algorithm. Next, second model should be using some averaged algorithms like random forest, and the third model should be using a advanced ensemble learning algorithm like XGBoost, gradient boost. There are also other ensembling algorithms. So you should build minimum 3 models, and then after doing the comparative analysis you can conclude. So whichever model gives the better accuracy or better performance metrics, so by looking at the values you can conclude what is the best model, and using the best model make the predictions and submit your results. So the client or end users just want to have a decision, the employee whether promoted or not. So in the submission file you should have only 2 columns as I mentioned, employee ID and promoted, getting employee ID and whether the person has been promoted or not. So done, and then accuracy here, accuracy is 93%, but recall value is little bit less than compared to the previous model XGBoost, 38%. Then making the submission using the GBM. So a new file is created and we are trying to know the count, how many samples classified into 0 class, how many samples classified into 1 class. So my conclusion over here is XGBoost model is better when you compare with GBM and random forest, because recall score is good. So one of the drawback of this data analysis is data is imbalanced. Understand, data is imbalanced means majority of the some samples are classified into 0 class and less number of samples into the 1 class. So that's why next you can improve the model building by making the data balanced. So I'm going to show you the same process and same algorithm, but I have to do the balancing. So for balancing, what I do is I'm going to use the technique that is called as smooth. I'm just running the same cells. There is a small modification while building a model. These steps are same. I just made a copy of the data. So look at here, I'm splitting the data. Yep, the data has been split, and after splitting data So in 0 class 37,605, in 1 class 3,501. Then I'm applying SMOT. SMOT is one of the technique, oversampling techniques. What it does, it just balance the data equal distribution of rows into both the classes 0 and 1. So we are importing SMOT from imblearn dot oversampling. So you have to install this package, then import the class, create an object, then fit the data to the SMOT, and then again knowing the values here. You see, after applying SMOT, equal distributions 37605 into 0 class and 37605 into 1 class. That means the number of samples have been added to the class 1, and then we have equal distribution, equal size. So on this I am applying the random forest. The steps, the process, everything is same, just we have made the changes. One change, that is we have added SMOT and then building a model again, and after balancing the data. So let us check the recall value with the 3 algorithms. So this takes time. I already run this. So after making the balancing of the data, you can see the accuracy we got is 79% with random forest, and recall score is improved to 68%. Right, recall score is improved to 68%. Then these things are same. Then when we have applied XGBoost, right, XGBoost, and the accuracy is 81% and recall score is 69%. So earlier with random forest the recall score was just 19%, but now you can see it is increased to 68%. So that's why first you have to make the data balance, then only build a model. So if you are training the model negatively, means it will give you the negative results. So after applying XGBoost, the accuracy is 81% and recall score is 69%. So we are displaying that and then making the submission. So when I applied GBM, gradient boosting model, the accuracy is 91%, but the recall score is 44%, and making the submission. So that's it. So I tried to show you how to analyze the HR data, where we are making the decision who is to be promoted and who is not to be promoted. And in the submission file you should have only 2 things: employee ID and then decision, promoted or not. So like this you have to build model for any problem statement using machine learning. I hope this will help you. This will help you in your problem statement if you have. And keep watching our videos. Do subscribe so that you can get the updated videos.